Good afternoon. We're going to get started right away because we have very little time. So please, everybody, take your seats. We got to get going right away. So here's what we're going to do. Okay, we got an hour. So Valerie and I talked, and I think what we're going to do. We're going to try to creatively combine the two sessions. Okay, I can see Paul Cruz over there, and Paul is a creative man, so I think he'll go with us. And I know Mr. Kadam is also on our side. So what we're going to do is Paul and Anil, because both your topics can be related to smart grid and the data coming from the smart grid, right? So will it be fair if I ask you, each of you, to do a 10-minute presentation? Because asset performance management also is analytics, right? Big data. So how about 10 minutes, Paul, hard 10 minutes, and then let's have a discussion, right? Yeah, I think both of you mentioned asset performance and asset health management. It's amazing how much of an opportunity that presents. Everybody talks about going from transitioning from a very reactive maintenance strategy to a more proactive and condition-based maintenance strategy. But when I look at an asset of a utility, the fundamental foundational building block of a substation, right? You look at the transformer, you look at the breaker, you look at all the different assets. Increasingly, digitization is going to take away, hopefully, all the CTs, the physical CTs, and with optical CTs, right? So that's going to keep changing. Transformers are also modernizing. But the fact of the matter is, today, as it stands across the world, if you take a sample across the world, there is very limited amount of maintenance, and the amount of inspections dollars that are spent utility by utility across the world is tremendous. That is tremendous dollars being spent, which means that is tremendous dollars that somebody is paying for. Yes. And you know who's paying for, right? Or it's a burden that the utility has to bear. So I think I see a tremendous value there for asset health and asset performance management and analytics. That's a good topic there. Yeah, it's interesting. I was particularly intrigued by Paul, your mention about the data and the cost of data. To give you an idea, as you know, in the United States, for example, almost every utility has gone through the process of going through and doing the roadmap and one conversation in the room, please. Thank you. Going through the process of doing the roadmap and strategy and the business case and doing technology adoption, and most of the utilities have kind of settled on platforms for analytics. But the challenge is that whether it be a hybrid data model concept, or whether it be hybrid cloud or private cloud or public cloud, whatever you do, or in on-premise enterprise IT infrastructure, the amount and utilities in a regulated environment, you just can't get data and flush it down the toilet, right? You have to keep the data, and then you keep it for now. You have collect more and more data, and you start storing the data. And before you know it, your data storage needs, requirements keep on, incrementally increasing over time. And I find that Centerpoint did a presentation last DistribuTech about the cost of data storage, and the amount of energy the data storage. Because typically data centers are flat consumers. They're not peaking consumers like a steel mill, for example, right? So this is base load. So you're gonna have to keep. You mentioned about renewables. This is steady base load, and this keeps on growing. That is one aspect. The second aspect is, I'd like to go back to asset health management for a second, because I think asset health management and asset performance management, if you just take the transformer today, right? Only the transformer. I suppose let's forget about all the other assets. In transformer monitoring, we call it something called total transformer management. Today there is transformer dissolved gas analysis that gives you some perspective on the age of the transformer, the aging model of the transformer, what's the life of a transformer. But then, if you look at larger transformers, you're looking at the total transformer analytics that gives you some perspective on the life of a transformer. I'm talking mostly in the transmission, sub-transmission side. Then you go to the distribution side, the cost of it's almost cost prohibitive to do DGA, dissolved gas analysis, and distribution transformer. You're essentially using, as we talked about, smart metering data to look at transformer load analysis, right? So any thoughts on Mr. either Anil or Paul, or your thoughts on asset health management, just from a perspective of what have you done and what you're seeing in the industry? The issue is, again, it goes back to the cost-benefit analysis, right? So I have worked with over 50 utilities on just this one topic of transformer load management, right? One utility that I worked with, the business case was very simple. they were having some feeders, and this is, I'm talking transmission, sub-transmission, where risk, the loss of failure and the truck roll, you can send a truck roll out, but transformers and generators are not something you keep 20 spare ones, especially not the big ones, right? And it takes a year to order a transformer, right? Sometimes, right? And to get a new transformer in. And spares have a cost. And then truck rolls have a cost too. Getting them fixed have a cost. And the downtime that it takes. So the business case was for monitoring in this particular case was just adding a basic monitoring. Just basic monitoring, not a detailed 9-gas DGA. This is basic monitoring, would tell them the transformer is gassing, right? That itself paid back in a matter of 3 months because it prevented 3 major outages in 3 successful months. And the vice president who signed off on this said, this paid off in 3 months because the cost of the downtime and the cost of being in the news, right? The prevention of that cost, although the soft and the hard benefits were way over the limit. So the cost-benefit analysis does have, and the reason I mentioned about transformers is because transformers are one of the largest assets, right? But then you didn't touch on one thing, right? Which is that yes, there may be the cost-benefit analysis for monitoring. There may be the cost-benefit analysis. You talked about purchasing new transformer versus retrofitting, because retrofitting old transformers have a tremendous cost and risk too. New transformers are much more easier. But then the fact of the other last part is how do you procure that, right? Then you look for the cheapest possible transformer, the cheapest possible price, then you know what, you're taking a risk, right? So anyhow, you were going to say something.
Yes, just to answer to Atos, the question of having too many data. In fact, this technology or solution that we deployed in France includes a platform, a data platform where we have just the correct data that helps us to manage our network. And so this kind of platform can have monitoring transformer data, but also flooding sensors, but also fault detection sensors. And so this platform helps us to have a global vision of data management. So I would like to bring one perspective to this.
So I would like to bring one more perspective on this whole discussion. That is the data acquisition part. Okay, and this learning is coming from our generation side. I'm Manish from GE. So the incubation of the sensors right at the stage of manufacturing is very, very important for us to make it the enabled part. So that is one strategy which we are feeling, especially in the wind turbines, if we talk about, or if we talk about the a gas turbine or steam turbine thing. But when it comes to the transformer side, when you say, so I would just classify into two. One is the transmission part of it, wherein the value is very high of the transformer. And the distribution part, especially the last mile distribution transformer, value is very less, and the maintenance charges also would be very less. So the data acquisition from the huge big transformers, there are close to 70 to 72 parameters on which the data acquisition happens. Analyzing those parameters require the data model, which is very, very OEM specific. So that is, because there is no general rule to that. It is very, very OEM specific, because the characteristics also depends upon the lot of OEMs, that if the temperature is, some of the OEM might be tolerant to higher temperature, but the other OEMs might not be tolerant to the higher temperature. So the standardization of those aspects are very, very important in terms of the data acquisition and in terms of the data model. I was hearing about the weather data also over here. The challenge what we are facing in India, that we have got the weather data, but how do we convert those weather data into the generation forecasting? So that transition from old weather data to generation forecasting, that model also in India varies from geography to geography. In northern part, in Ladakh part, it might be a different model which we use, but when we go to the middle India, the tropical region, then that will be a different model used. So the point which I'm trying to bring in, that the sensors plays very, very important role. like in distribution transformer, we have got an experience where we are monitoring just 5 parameters. And basic parameters, the lug temperature, the oil temperature, the oil level, and one more. So this is flagging. This gives a flag. Then the acquisition part has got another aspects, whether you want a real-time acquisition, whether you are ready to pay for the real-time acquisition and manage those data. Because if you are collecting the real-time data, you have to store somewhere that data. Or you want a batch mode data also. So it totally depends on the classification of the asset, how much important it is, and how much important it is to get the real-time data and analyze it in real-time way.
That's very interesting. Transformer modeling is a very old stuff. I mean, it's not new, right? The Duval's triangle and the IEEE models and the Seagrave models are very well known, right? But then when you talked about sensors, there is one aspect that we have to factor in with the increasing amount of sensors is that issue of cybersecurity, right? Which is that the more sensors that you have, the more data, more entry points you have into the grid. That really brings into picture the real danger that we face. That from somebody breaks in, what will be the risk associated with that? That is something that we have to consider, and we have to factor for that. How are we doing on time? Okay, good. So that is the second part. The third part I'd like to that was brought up as part of the presentation was about the whole drone, inspections as well as energy management. So I'd like to ask Paul, since you brought that up, tell us a little bit about the drone project. Well, I found that very, very intriguing and very interesting.
Yeah, I think many utilities and NADS is doing it as well. But what we have done is starting from the inspection itself. And you know that PG&E in the US is the largest world bankruptcy, $31 billion, Chapter 11, right? Because they sweated the assets, they didn't do the inspections of their power grid, they had a transformer blow up. And evidence is that
they are my customer. I know nothing about what you're talking about.
So as they not, or they were my previous one, but so it is proven that they sweated the inspections, and that means from one year to the other they didn't do the regular inspections, they didn't do the vegetation management. So there is a legal case. I think it's still ongoing, the legal case, and they will be more or less prosecuted, I guess. So. What we are doing is from the inspection itself, trying to optimize, because as we said, it takes a lot of efforts. It's one of the biggest OPEX for utility, doing this inspections of power lines and the vegetation management associated with it. So we're going to improve the data quality. There are a lot of problems. We talked often about digital twin. The problem is how do you put in place data governance and digital and data accuracy into the mix, because either the position, either the type of pylons, either even the vegetation that is around, what kind of trees do you have around it? And you can apply after modeling to say, hey, I usually do these inspections every 6 months or 1 year. We can say, oh, actually, the essence of trees have been detected to be beech trees or oak trees, and therefore their growth can be predicted more accurately based on rainfalls. So you can do inspections more accurately to do with these cycles and so on. And then, of course, what you're going to try to do is to detect defects. And the advantage of the drone, and with high quality images and so on and so forth, not only you detect the problem, but you're going to have all the environment. So generally speaking, when you detect a default in the classical way, you need to send a team to evaluate what needs to be done. And here, you with one pass, you have, because you have all the data, you can therefore also better plan the work order that needs to be done behind. And it's not just for vegetation; it can be for corrosion. And so we're working. We were very fortunate last year to win a mega deal in the US and the UK with National Grid, and we are developing with Google Cloud, but also Google AI. ability to categorize per their levels of corrosion, for example, if there are incidents and so on. And the idea is not to develop too much software, but to use the deep learning models to categorize that automatically.
Interesting, actually, because and the reason I keep stressing back on operational expenditure elements here is because in the Indian context, as we see the discoms, and I keep hearing about distress at the discoms, I think there is two ways about going about doing this thing, right? Either you keep on increasing your revenue, or you keep on cutting back cost, right? So cost reduction has to be a targeted element of, so everything, asset performance management, asset health management, increasing data analytics to improve the efficiency of the utility top to bottom.